are going to discuss one of the important problem in the field of electrical engineering and electronics. See, the heading is electrical instruments and measurements. Okay, in the subject electrical instruments and measurements, I have chosen one numerical problem. So this problem you can expect in the gate level examination for students who are appearing for gate exam or TANSET exam. They can also expect this kind of question. So this is very important problem, but the concept that is being involved into it is very simple. So I had chosen this problem. So let's get started. So this is the problem. This mainly deals with about the instruments. We have electrical instruments and measurement means it is the study about instruments, various instruments that are involved in electrical measurements. So we are going to study about the analogy of these instruments, how the deflection is being produced, what is a controlling torque, a deflecting torque, and the angle that has been produced when a magnitude of current happens to flow through a wire. So these kind of concepts and all you will be discussing in this lesson, electrical instruments and measurement. From this lesson, I have taken this numerical problem. So let's get started. Okay, so before getting into it, I'll read the problem what is given over here, and then I'll try to explain it. Then we will extract the data from the question and we'll start solving this problem. So the question is the torque of an ammeter. We know ammeter is an instrument used in the measurement of current. Okay, so the torque of an ammeter varies as the square of the current through it. So here the entire problem depends on this condition. Okay, the torque of an ammeter. So when a current passes through an ammeter, there will be deflection of the needle. So when a needle gets deflected, so we will be getting a deflecting torque. Okay, deflecting torque is being produced in the needle of an ammeter when the current is being passed into the instrument. So the torque of an ammeter. So when a current is passed, the torque is created in the ammeter needle. So that is what they had given. The torque of an ammeter varies as the square of the current through it. So when the torque is produced in the ammeter, the value of the current which they had observed is nothing but it is in the square of the current. Okay, it is not in power of 1, but it is in the current is in the power of 2. Okay, so you will be getting like 2 twos are 4, or it might be 3 squared or 4 squared or 5 squared, like that. That is the square of the current. Okay, so this is what is being told over here. If a current of 5 ampere produces a deflection of 90 degree, so again when a 5 ampere current is passed through the ammeter, there is a deflection by the needle, and the needle deflects to 90 degree. They are telling that is what when a current of 5 ampere happens to pass through the wire through the ammeter instrument, a deflection of 90 degree has been observed. Okay, now they are asking what deflection will occur. They are asking the magnitude of the deflection. I mean the magnitude or the angle of the deflection. What is the angle of a deflection when a current of 3 ampere magnitude happens to flow through the instrument? Okay, so this instrument there are two types of instrument. One is they are asking for spring controlled instrument, and another one is a gravity controlled instrument. Okay, so spring controlled instrument is different from gravity controlled instrument. Okay, so when you get into this kind of electrical instrument and measurement, you will be knowing what is meant by spring controlled instrument and gravity controlled instrument. So first, just for the purpose of solving this problem, I will just tell you the expression and the formula, the analogy, numerical analogy that is being used in various types of instruments. Okay, so this is the numerical problem. From this we need to extract the data. Okay, so they are asking us to find this condition for the spring controlled instrument and this condition for the gravity controlled instrument. Okay, so for a spring, first we take the case of a spring controlled instrument, and for this spring controlled instrument we need to find the deflection when a current of 3 ampere happens to pass through the ammeter. Okay, for spring controlled instrument. Okay, I'll rub this part. Okay, for spring controlled instrument, in case if it's going to be for the spring controlled instrument, if it is spring controlled, see the formula is the deflection torque. Okay, the deflection torque TD, I am denoting the deflection torque as TD. This TD will be directly proportional to the magnitude of the current I. Okay, deflection torque will be directly proportional to the magnitude of the current, okay, that is passing in through the ammeter to produce a deflection. So TD is directly proportional to I. This is comes for only for spring controlled instrument, okay, for spring controlled instrument. So how about you have another torque? You have another torque called as TC. TC is nothing but controlling torque. This is called as controlling torque. TD is a deflecting torque. TC is controlling torque. This TC controlling torque will be directly proportional to the theta. It will be proportional to theta. Theta is nothing but the deflection that is being produced by the ammeter needle when a current passes through it. So these are the two important expressions for spring controlled instrument. That is, the deflecting torque is directly proportional to the current that is flowing through the meter, and TC is the controlling torque that is directly proportional to the deflection that is being produced in the meter. Okay, TD is directly proportional, TC is directly proportional to theta. But here they have given the torque. Torque is nothing but the deflecting torque. Okay, they are telling the torque of an ammeter varies as the square of the current through it. So the TD is directly proportional to I, but they are telling this the current will be the square of the current. Okay, here the power of the current is 1, but here they are telling the square, the current has a power 2. This is square of the current. So it will be TD. So I'll write like this. So it will be TD. TD will be directly proportional to I square. Okay, now TD will be directly proportional to I squared. You cannot take TD directly proportional to I. This is a common analogy, but here in this problem, they have specifically mentioned that the torque is directly proportional to the square of the current. So TD, that the torque is directly proportional to the square of the current. Okay, so TD expression is we have obtained, right? So how about TC? TC is nothing but the controlling torque. TC is directly proportional to theta. So they are not mentioning anything about this deflection here in these two lines. Okay, so TC will be directly proportional to theta. Okay, so now if the current happens to be, I mean in a meter, if the meter needle is at rest in the ammeter, if the deflecting pointer is at rest, means at that condition TC will be equal to TD. Okay, TC will be equal to TD. That is, the controlling torque will be equal to the deflecting torque. Okay, so this is a condition when the pointer is at rest. The pointer is at rest. When the pointer is at rest, the controlling torque will be equal to the deflecting torque. Okay, so here TC equal to TD. Okay, that is, the controlling torque will be equal to the deflecting torque when the pointer is at rest. So that is the condition that we need to apply over here. So when TC equal to TD, what will happen? When TC equal to TD, it will be theta will be directly proportional to I squared. Okay, so TD is I squared, TC is theta. So when that is, TD is directly proportional to I squared and TC is directly proportional to theta. Therefore, I can take theta is directly proportional to I squared. Okay, theta will be directly proportional to I squared. Okay, so this is the expression that I need to take for solving this one. Right, so theta is directly proportional to I squared. So here theta, what is theta? That is, a 5 ampere current produces a deflection of 90 degree. So the 90 degree is nothing but theta. 90 degree is nothing but theta. Is directly, so 90 degree is directly proportional to I squared. I squared is 5 squared. 5 squared is 5 whole squared. Right? This one. So now they are asking what will be the deflection will occur if a current of 3 ampere happens to pass through the instrument. If a current of 3 ampere means it will also be square of the current, that is 3 squared. 3 squared deflection that we need to find. What is the deflection? Okay, what will be the deflection? So we need to find the deflection, the angle of deflection over here. So for that what we have to do is, I'll rub the board. So we have got theta is directly proportional to I squared. So I am taking this entire thing. So that is for 90 degree. This there is square of the current is 5 squared. So if the current is 3 ampere, that is square of the current 3 squared, what will be the deflection? So that will be nothing but 3 3s are 9 into 90 degree divided by 25. So which is nothing but 9 zeros are 0, 9 nines are 81 divided by 25. So 810 divided by 25. So 810 divided by 25 is nothing but 32.4. So the answer is 32.4 degrees, because we need to find the deflection. Deflection is given in degrees. Okay, 32.4 degrees. So this is the value. So we need to find what is the deflection. What deflection will occur for a current of 3 ampere. So for a current of 3 ampere, 32.4 degrees is the deflection for spring controlled. It is for spring controlled instrument. Okay, this is for spring controlled instrument. Now we'll get on to the gravity controlled instrument. The second thing is gravity controlled. Camera ஒரு வாட்டி பாருடா image எப்படி வருதுன்னு. So now the second case is for gravity controlled. It is for gravity controlled instrument. Gravity controlled instrument. Okay. For gravity controlled instrument also you have two different torques. That is a TD, that is a deflecting torque, and TC. You have TC also, which is called as the controlling torque. Okay, so here for TD, that is for deflecting torque, TD, as far as a gravity controlled instrument will be directly proportional to I. It will be directly proportional to I, but in our case we are looking out for the square of the current. Okay, because it has been written as the torque of an ammeter varies as the square of the current. So this torque of the ammeter varies as the, so as the deflecting torque varies, the current also varies in square. So that is, we need to put TD is directly proportional to I squared, right? For TC, that is controlling torque. Here, as far as a gravity controlled instrument is concerned, the TC controlling torque is directly proportional to sine theta. So in the previous case, that is in the spring controlled instrument, we saw this controlling torque is directly proportional to theta. Here it is, here in the gravity controlled instrument, it is directly proportional to sine theta, that is sine of the deflection. Sine of the deflection here. So TC is directly proportional to sine theta. So again, when at rest, when the pointer is at rest, we have TD will be equal to TC. That is, the deflecting torque will be equal to the controlling torque. So what I'm going to put is I squared is directly proportional, will be, so TD and TC, if they are equal, I squared is directly proportional to sine theta. So I squared is directly proportional to sine theta. So here we have two different things. In the first condition, and a current of 5 ampere, that is pi squared, produces a deflection of 90 degree. So it will be sine 90 degree. Sine 90 degree. Okay, this is sine 90 degree. Now they are asking if a current of 3 ampere, that is 3 squared. Now what will be the value? What will be the angle of deflection is what they are asking. So similarly, what you need to do is the same thing. Here we need to put 3 squared into sine 90 degree divided by 5 squared. This will be 5 squared. So this will be 3 3s are 9 into sine 90 is 1 divided by 5 5s are 25. So this will be 9 divided by 25. So what is 9 divided by 25? 9 divided by 25 is nothing but 0.36. So this value is 0.36. 0.36 is nothing but theta. Theta is equal to 0.36. That is theta equal to 0.36. Okay. So now degrees. So now what is sine theta? Theta. This will be. I mean sine theta. This is sine theta. Okay. This is sine of the deflection. Sine theta is equal to 0.36 sine theta equal to 0.36 degrees. So we need to find the deflection theta. So theta equal to sine inverse of 0.36. So sine inverse of 0.36 will be sine inverse of 0.36 equal to 21.1 degrees. So the answer will be 21.1 degrees. So this is the deflection that has been produced when a current of 3 ampere happened to pass in through the instrument. Okay, here 21.1 degree is the answer for gravity controlled instrument. Thank you all.